Welcome to the November meeting of the Integration Down Under. Just to go over, we've got our organizers, Martin, Dan, Renee, Wagner, and myself. And tonight we have Justin Yu, an MVP for Azure and Developer Technologies, working for Deloitte. It's going to talk about a very opinionated way of writing ARM templates. So without any further ado, I will Justin can take over presenting if he wants to, and then we'll get started.
Good evening, everyone. Tonight, I'm going to talk about ARM templates, how we can write ARM template in a very efficient ways. In here, the term efficient is very subjective, so you can say it's arrogant way, maybe opinionated way, yeah, etc. My name is Justin. The Microsoft MVP for both Azure and Developer Technologies, which is particularly about the ALM or DevOps area. And these are my social media profile. So if you like, I probably need to start this one first. This is purely my personal opinions, not representing or affiliating or any sort of any piece of information used in this session is not related to my employer. So yeah, that's it. So here's the agenda tonight. This is all about ARM template writing, testing, and deploying. And finally, I will share some tips to manage ARM template deployment histories. So if you have any questions, leave the message on the message board, or leave any message through the Twitter by mentioning Integration Down Under or myself. So before starting, I'm going to run some the Azure DevOps build pipeline because it takes time. Now, so here's the ARM template build pipeline. So I'm just starting to build. So it's going to be built, and as I said, it takes a little bit of time. So before starting, I'm going to just make sure this build is not being broken. Okay, it's started now, and I'm going to start kick off another logic app to manage deployment history stuff. It takes more than 15 to 17 minutes, so it's better to start right now. So this is the one. I'm going to, run this. So when you see the deployment history here, it has a bunch of deployment. It's now, because I'm just starting to run the deleting all the deployment history, it's showing deleting. So once everything is done, all the deployment history will be gone. So I'm going to touch this later on. So let's get back to the slide. Now, to begin with, I probably need to slightly touch what the ARM template is in case anyone who are not familiar with. So here, ARM stands for Azure Resource Management. So when you create a resource on the Azure, you can do it directly on Azure portal or by writing a template. The template is a big JSON file to define all the Azure resources, and it can be used over and over again. All the resources defined in a template is deployed into one resource group. So the resource group is kind of a global, the logical groupings, not the physical resource location. So the ARM template can be reusable over and over again for the different resource groups, and anything not declared in the template won't be deployed. So if those resources are no longer necessary, we can simply delete the resource group so that all the resources within the group are deleted at once at the same time. So it's very easy for the resource lifecycle management. Okay, So now let me tell you how to write ARM template more efficiently. So I'm going to say not to use JSON anymore from now on. So instead use YAML for your ARM template writing, because YAML is a superset of JSON. So there is no harm to use YAML because it's interchangeable. So we can easily convert YAML to JSON or JSON to YAML whenever we necessary. And one of the reason is using YAML is YAML actually brings better readability because it removes all the opening and closing brackets and braces that defines the JSON object. And by removing those opening and closing brackets, which significantly reduces number of syntax errors as well as a number of lines. And even better, YAML supports comment while JSON can't do it. So this is actually a huge benefit of using YAML for ARM template authoring. So let's have a look at this picture. This is a typical ARM template written in JSON. This is about writing the virtual machines, and there's nothing wrong with this. It's actually a working example. However, can I ask to find a square closing bracket amongst of all curly braces? So you can find it if you have a Hawkeye, and you can easily find it, but it maybe takes some time. And actually, there is these square brackets, and it's very hard to find. And if the size of ARM template is getting bigger and bigger, it's really hard. And depth and deeper, it's really hard. This time, let's have a look at the other picture. The exact same ARM template, but which is written in YAML format. There is no opening and closing brackets and braces. And this gives us much better readability improvement. And also it reduces a significant number of lines, and it will reduce the number of syntax errors as well. The problem of using the YAML is, the ARM template doesn't officially support YAML. It only supports the JSON format at the moment. But as I said, YAML and JSON are interchangeable, so we don't have to too much worry about that thing. But we have to give up using the Visual Studio or Visual Studio Code, the visualization, if we keep using YAML file, YAML definitions. So, as I said, if we want to use YAML for your ARM template definition, probably you need to have a tool convert it to YAML into JSON. So this YAML CLI is a very small and convenient command line tool. So it is written in .NET Core, so it can be run on any platform, including Windows or Linux or Mac. The purpose of using this YAML CLI is very simple. So what it does is to convert ARM template written in YAML into JSON or vice versa. So if you are interested in, it's the open source and GitHub. This is a GitHub repository. So if you are interested in, visit that GitHub repository and play around it. Now, let's have a look how we can convert YAML into JSON format. So this is the GitHub repository, which is it's called as a quick start template, and it contains all the collection of the ARM templates depending on various different use cases. So let's pick up anything written in YAML, written in JSON ARM template. So yeah, just use what is it? The Kubernetes template. Get the row URL, this one, and copy this, and back to the Visual Studio here. So we get the file, and now this is how we can use the YAML CLI here. We can use YAML CLI within our local, or we can actually get the JSON ARM template directly from the internet, like this. And when we download it, it automatically converts into YAML file, which it just created here, right? And whatever we need to do things, and when we finish the authoring, and then we can convert this YAML file into JSON object, like this. So JSON file has been created, right? So JSON file has been created. Okay. Now this is the fun part. As I said, YAML we can use in YAML we can use comment. So, and there are many chances that we might need to comment out some kind of parameters or some kind of lines, and that's kind of a temporary solution. For example, so we comment out these parameters, right? And once we save it and generate the JSON file again, and here we are having DNS name prefix like this, but if I regenerate again, it's gone because it's commented out, right? So this commented part is not reflected into JSON template creation. And what after we decided this need to be back to the part of template like this, and once we generate the JSON template again, it comes in, it's back in like this. So this is the beauty of using the YAML for your template authoring. Also, if we are usually we are in a collaborative environment, so probably we can do some kind of leave some comment. This is something like this. Then save it. Actually, this the comment is not doesn't have any impact on this generated JSON file, right? Yeah. So in this kind of comments, we can't do it in JSON because it's not a spec of JSON. So yeah, think about using the YAML file here, and I'm pretty sure that if you are getting used to using the YAML for your template authoring, and you can't go back. I think I'm pretty sure. Now, I'm going to show how, as a DevOps, we can use this YAML CLI into how to integrate this YAML CLI into Azure DevOps, because it's a small the command line tool, and which is very well integrated with the build pipeline. So, it's done. Okay. So this is the Azure DevOps the build pipeline task definition. I installed the first task is to install YAML CLI. So, and the YAML CLI, that repository actually provides the predefined the installation PowerShell script here. So we just simply use that, and it actually download the latest version of YAML CLI into your build pipeline, and we can start from there. And after we install YAML CLI, then we can convert all the YAML based template into the JSON file. Then once we finish it, and we can test it or create the artifact for our release pipeline. So I'm going to touch those testing scenarios after that. Now, another thing I want to emphasize is here is the relationship between parameters, variables, and resource definitions. So as you can see the title, I would not recommend using parameters for your resource definition. Parameters only takes inputs from outside, like the user inputs or CI/CD pipeline. And the parameter values should be passed into the variable section to manipulate all sort of the other values can be which should be used by resource definitions. So as I said, we shouldn't use parameters for your resource definition. Actually, there is no harm. It's completely legit to use parameter values for your resource definition. But that doesn't necessarily mean this is a efficient way or productive way. So think about this example. Sorry about the noise. Think about this example. If you have more than 100 parameters in your ARM template, and you have around 10 variables in there, right? Then when you build a resource definition, and if there is something wrong on your resource definition, then we have to debug it, right? And usually the parameter section are at the top and variables at the next, and the resource definition comes the other, right? And then we have to find what the problem is, and by scrolling all the way up, all the way down, over and over again, right? If the number of parameters getting bigger and bigger, the number of the amount of scrolling is also bigger and bigger. Now, if we pass all the parameter values into variables, and variables takes care of all the values manipulation, then we don't have to worry about we don't have to scroll too much all the way. We don't have to scroll all the way up and down, right? Only we take a small amount of bits on the resource section, the variable section for to find some kind of bugs, right? So, yeah, I would suggest use variables should talk to resource section only, not parameter section. Also, the function, there is a function section actually. This is not very popular, but if you can use functions as much as you can. What it does is to simplify all the complex expressions, right? And as the name suggests, the function is reusable within the ARM template. So what that means is this is a kind of example. So I deliberately use the YAML expression here. So there is a function section, and functions has basically the array object, and within each section, it has the namespace, which to avoid any sort of naming conflict. And each function has the list of the functions. We can define it, and under the function, it has a list of parameters and output. So output is basically the return value, and here there are parameters. That parameters is not the same as ARM template parameters, right? So we cannot use the ARM template parameters here. Instead, we use the function parameters. So even though the name is the same, but the parameter here is representing the function parameter. So this is a kind of example. So within the variable section, we have a value. And if you are following some kind of naming convention by defining all the Azure resources, then those resources have very similar naming, right? With slight differences. In here, for example, we have a full the Azure resource name, but if we pass that name with some the variations through the function, so function app will have the same name with the func app suffix, and logic app will have the similar style but different suffix. The service bus will have the same similar style but different suffix, something like this. They are all using the same function but different the parameters. So this is how we can reuse the functions over time. Also, this is the output section. So output section is also very underestimated. Once the ARM template is deployed, the output section actually visualize the deployment results through this. So for example, if we deploy something and like the deployment key or deployment link or something like that can be retrieved directly after the deployment through the output section. So this output section is particularly very useful when it is run within the CI/CD pipeline, so that all the following tasks can have references from the output values from the previous task. So this is an example. So after the deployment, for example, if we run a deploy application inside, we can directly get the instrumentation key by after that, or event grid topic endpoint, we can get that directly from the output, or like something like a storage account key, we can get that. Now, let's talk about testing. So it's like how can we test ARM template, right? So in your usual every day-to-day coding, like C# coding, something like this, we do usually unit test or integration test. But how do we test ARM template even before deployment? It's kind of very tricky. So there are the Cmdlet, PowerShell Cmdlet here. It's called a test as a resource group deployment. So this is good, but only if it is the template is invalid, right? So if the template ARM template is invalid, it actually returns an error message like this. So this is also all about the validation, ARM template validation itself. But if the template is valid, actually it returns nothing. So so think about this. The validation, so I mean the ARM template is valid. That doesn't mean we are deploying the correct Azure resources. We never know. So using this the PowerShell Cmdlet we can't test the deployment behavior other than validation. Also, the PowerShell Cmdlet is very bad for error handling. So think about the blue background with red the error messages. Sometimes it's very hard to read and not very informative, something like this. So I wouldn't recommend you use PowerShell Cmdlet for the ARM template testing. Instead, use Azure CLI for your the ARM template testing. So this is the command, and this is how we send the Azure CLI for your ARM template testing. And once it is done, it actually returns the JSON object. If there is an error, it contains error object. If there is no error, it contains all the validation result. Right? So including what kind of the behavior will be expected. Also, there is a good PowerShell testing framework which is called Pester. So the Pester is very good for your PowerShell script testing, and it follows the BDD style testing. And the good thing is Pester comes with Windows 10 out of the box. So therefore, of course, you can install the Pester through the GitHub repository. Therefore, combining both Pester and Azure CLI for your ARM template testing is a good practice. So this is a sample code for using Pester. So first of all, the script needs to describe what the test is about and set up the context boundary so that what the context, what test context is. So this is about testing, logic app deployment testing. So within the context, the Azure CLI command is run and the result is captured like this. And with this result, we can check the deployment status, which is successful or not, or the logic app is enabled or not. And finally, logic app has a the correct name or not, something like this. So if this is just simple example of using logic gap testing. But if we test ARM template for your storage account or app service instance account, app service instance, something like this, and we can also test the location would be expected value or SKU value, it's expected one or something like this. Right? Now, this is how so once we finish writing the Pester testing script, we can run like this, and the result will be very familiar. Like yes, it's a normal the testing library testing result, and also it supports the test result export. So after the exported XML file, we can publish into your preferred build server or the CI/CD pipeline, so that this is the screenshot taken the Azure DevOps. So we can upload those the test results, and that based on the test result, the build pipeline actually visualize test is successful or not, and how many tests were passed or how many tests were not passed or something like this. Right. So I'm going to show the test result from the previous demo. So I have run. So this is the initially I run, and as I showed, the first of all we install YAML CLI, then we convert the old YAML JSON file into YAML file into JSON file, and we install Pester, we install Azure CLI, and we run the test, and finally we get all the artifacts for the release pipeline. So in here, so test summary says, okay, test is successful. And this is the test result because we run the Pester and the test result is uploaded into the build pipeline. Okay. Now, we are moving into the ARM template deployment. But before mentioning the ARM template deployment, I will touch this one. Usually, if you are in a big organization which have multiple Azure subscriptions, then you probably need to apply some kind of access policy on each subscription based on the resource group level or even in the subscription level. But recently, the management group has been generally available, which is the controlling all the access policy. So management group is basically having the hierarchical structure. So each management group has its own access policy and some access policies inherited by its parent, the management group. And what we need to do is subscription. Each subscription can belong to one the management group. So that all the access policy can inherit from there, right? So this is some kind of good thing. So we don't have to worry about we don't have to manually assign or allocate all the access policy directly on subscription level or resource group level, right? Instead, we just create a management group and assign those subscriptions into the management group. This will be much easier for your access policies to manage access policies. And also, this is about the writing ARM template. But I just want to bring in here that one resource group should be written in one template. So, the one template, one resource. This approach is very useful, practical, because this makes more sense. It only takes single responsibility. Of course, there are chances that some resources are better go together. For example, app service instance, for example, it usually comes with app service instance definition as well as the app settings definition. So those are two separate the resource management. But is usually goes together. So in this case, it's better idea to use one template for both the resources. So except these kind of cases, one template, one resource approach is generally better idea. And if by doing so, we will have multiple ARM templates. So by doing so, combining those templates together for different circumstances increase reusability. Also, this approach actually increases maintainability. So if there is a problem on a one resource template, we only fix the template. But if we have one template with multiple resources in one template like that, and this kind of maintainability will be very problematic. So if we need to deploy multiple resources by combining things, and this kind of orchestration can be done by either linked template or CI/CD pipeline. I just mentioned here that use the linked ARM template. Right? So this the linked ARM template is very good, but we need to be careful for using that because it's very good for the deployment orchestration in a parallel manner. But I wouldn't recommend using that unless we have a specific reason to do so. What that means is in order to use a linked template, and then we need to publish the child templates to be publicly accessible, or at least we need to have the access token or SaaS token to be attached to access that the child templates. Right? This means we need to upload those child templates to run the linked template, and even for testing. So if we want to test linked ARM template, then those child templates has to be uploaded beforehand. And those kind of uploading is kind of, to me, is an extra step, which I don't see much value here. And I think this is kind of critical to use the linked ARM template. We can only use either parameter object or parameter file at the same time, not both. So in many cases, if we need to pass some sensitive information like access key, this usually passed as a parameter object rather than parameter file. So in that case, we can't use the linked ARM template, and we can't use parameter file. So however, for individual template deployment situation, we can use both parameter file and parameter object at the same time. I think this is a kind of drawback. So instead, I would suggest using CI/CD pipeline to take care of those kind of the orchestration. So if we use the CI/CD pipeline, which is specifically in the release pipeline, we don't need the external reference for child templates. Actually, there's no concept of child templates here because they are all staying in our pipeline, within our pipeline. Also, we can use both parameter file and parameter object at the same time. So the most default values are defined in the parameter file, and only some environment specific values or sensitive information are passed through the parameter object. The downside of using this approach is that usually the release pipeline is run as a sequential manner. Right? So the linked template we can use the parallel approach, but this CI/CD pipeline we have to stick on the sequential approach. But the good thing is, as a DevOps, supports parallel deployment orchestration, so which is a good thing. Now, I'm going to show how we can orchestrate ARM template deployment within CI/CD pipeline rather than linked template. So there is an ARM template dependency. So the first ARM template will be deploying table storage, and there's a storage connector which has a dependency on the table storage, and the logic apps which has a dependency on both storage connector and ARM connector. So this is so there are 4 ARM templates will be deployed, and this is the order. Now, so this is the release pipeline for ARM template deployment. So first of all, storage account has no dependency on anything, so that need to be deployed the first. And the table storage connector, it has a dependency on the storage account here, so it comes in the middle. And finally, logic app will be deployed at the last because it has a dependency on those 2 connectors. Okay? And now I'm going to create a release for this to see how it's going. Now we create the release. Now it's gonna be deployed. Oops. Yeah, it's gonna be deployed now. We'll see how it's going. So yeah, it started deploying. So we'll see what happened next time. Now, let's have a talk about the ARM template deployment history management. Probably you might have heard of this number, 800. This is the maximum number of deployment in one resource group. So in other words, we can only deploy ARM template 800 times, up to 800 times in one resource group. Therefore, that means if we deploy 800 first times in one resource group, that deployment will fail. Therefore, we need to carefully monitor whether deployment history, the number of the history exceed or not. This is particularly important, very important, when you are working with logic apps or API management or data factory, as they consist of many child resources. Right? So before deleting, probably it's a good idea for backup, right? So for future reference. So before deleting, we need to back up this deployment history into somewhere else, like as a storage table, a table storage, or Cosmos DB, or blob storage, whatever we want. So let's have a look how the ARM template deployment fails. So I just kicked off the ARM template deployment, and it's failed because the error message says the exceed the quota of 800. Right? So it's failed because of that the specific resource group has already have the 800 deployment histories. So we need to figure this out. So how can we manage those deployment histories? We can use the ARM REST API, and each deployment history can be deleted for about 30 to 60 seconds for one deployment history. It takes very long time. So we can use REST API directly, or we can use PowerShell Cmdlet or Azure CLI. However, if we use PowerShell, in order to delete the entire 800 history, it takes more than 6 hours because the PowerShell doesn't support parallel execution for within the loop. But instead of using PowerShell, we can use the logic app because logic app supports parallel execution within the loop up to 50 times. Right? So if we maximize using the for each loop up to 50 times, and instead of taking 6 hours, it takes about 15 to 17 minutes to delete all 800 entire histories. So I will show you about simplified logic app workflow here. First of all, we fetch the list, all the list of deployment history here, then loop through each deployment history, right? And store those history into somewhere. In here, we use storage account, storage table, then delete the history. And this is done by looping, right? The interesting thing is it takes 2 minutes. And if we run that, actually it takes only 89 loops, 89 histories. I was expecting to get all 800 histories, but for some reason, it only takes 89 histories. I think this is kind of the performance, the consideration by logic app. So we have to put another loop outside this workflow. Once we put this loop, it takes 7 times, right? And that 7 times will cover the entire 800 histories. Now, at the very beginning, we actually run the logic app to delete all the deployment history. So let's have a look at the result. I deleted, where is it? Yeah, so where is it? So I run this history cleaner, right? And it finishes, it finishes now, and it takes about 7 minutes and 7 minutes and 30 seconds. And as I show you, before that, the history was all deleting, and now it's all gone. So no deployment history left here. So we have deleted all 800 histories within 70 minutes, in about 70 minutes. Now, what we have covered today is how to write ARM template and how to test ARM template and how to deploy ARM template, and finally, how to manage those 800 ARM template deployment histories. So this is it from me. Any questions?
Justin, this is Bill. Can you hear me?
Yes, I can hear you.
It's interesting. I was building some of the ARM templates this week, and I was able to get comments into the JSON.
Okay.
By doing a //
Mm-hmm.
So, which is about the same as you've done with the YAML files, I understand. But
so JSON spec doesn't allow comments like using the / something like this. But so when you see the gist or something, and I don't think most of your other tools won't allow the comment line, and also it will give you an indication that this is not correct or something like that. So I wouldn't recommend, even though some kind of tools may allow that, but that this is not a spec.
Okay.
So I would recommend to use not to use the comment on the JSON side.
Okay. The other one is, so by deleting that deployment history, does that get past that 800 limit? Does it?
Yes, it has 800 limit.
But if you delete them all, then that means you've got another 800?
Yes.
Okay.
So it's like you can run this at once, like every day. Like every day, they run this one to delete all the histories, or sometimes you can run like once you finish deployment and back up and delete the history straight away. That's kind of another approach, but yeah, that's it.
And on your in your logic apps, when you're getting the deployment history and you only get like 89 of them, does the does that API call have a next link in the header by chance?
I don't know. To be honest, I haven't checked that. I just use the logic app, the API connection.
Okay.
The logic app side built-in connector.
Because
So
I know we do a lot of work with the Azure billing files, and that's the way they work is that you get the first bunch of billing data back, and then in the header there's a next link that you have to call to get the rest of it.
Yeah, I haven't checked that, to be honest. Probably, but that's a good suggestion. Probably I will have a look next time.
If you just go into your run where you did the run, you'll see it in the first header if it's there.
Okay, let's have a look at that now. History cleaner.
Just one note, guys. After we go through those ones, Aaron has a question on the conversation tab.
Okay.
Okay, so when I have to fetch all the deployment histories here, and output value says, no, not really. It only returns the individual the ARM template histories, not the link itself.
But if you look at the raw outputs, what I'm asking,
yeah, this is the raw the outputs.
But up at the top where you do get the all, isn't that?
Oh yeah, here. Oh yeah, here. Next link here. Okay. So yeah. So there is some next link at the bottom. So we can use this link for the next the fetch next 89 fetches.
Yep. Okay. So I thought it would be strange that they didn't put a next link in there if they did. So yeah, Aaron's got a question about writing logic apps in YAML.
Yeah.
Can you?
Yeah. So his question is, did you try to write logic apps in YAML? There is any restrictions or challenges? I'm assuming it's like if you're creating it from scratch, just like Visual Studio Code is doing today, but instead of doing JSON and YAML.
Could you say again, Aaron?
You can unmute yourself, Aaron. Oh, he's got an issue with his mic. So basically, if can you it says basically, let's see, just on using YAML over JSON for ARM templates. What was your experience like writing logic apps in YAML? Any restrictions, challenges encountered for the complex logic app scenario?
That's actually a very good question. So if we are not using YAML, I mean, we are using the traditional JSON approach, and we can get a help from the Visual Studio or Visual Studio Code, and also we can get a help from the IntelliSense, right? But if we are using YAML, we cannot get any help from that thing, and we cannot visualize anything. So it's completely the writing by hand. But yeah, so but usually many actions are very similar to each other. And also many actions are from the API connection. So I have been using the YAML approach for more than half a year. So I don't see any issues from my side, and my clients actually started using this YAML approach, and yeah, they are pretty happy with that. But for their junior developers, they prefer using the visualization tools. But if they get more experience, and they can switch into the YAML side. Does that answer your question?
So would be the case for when you're doing the logic apps, for example, to design everything, have the JSON, then run the CLI to get the YAML version, and then on that, just do the comments and the parameterization?
Yes, yes. So when you use the YAML and when you want to some kind of comment needed, or if you want to disable some part of the ARM template, and simply comment out and convert it into JSON file, and that won't be happening on the JSON side.
Mm-hmm.
So Aaron said that yes, that so the YAML approach is more relevant for other Azure resources than Logic Apps.
Yes, so it's for the ARM template in general. It's not too specific to Logic App side. So, but as I said, the Logic App is a part of the ARM template, so we can still apply this approach into building Logic App as well.
He said thanks.
Thanks for asking, Aaron.
Any other questions? Well, if not, thank you very much, Justin, for that. Gave me several things to think about because I've been doing a bunch of stuff lately with ARM templates, so we'll have a bit of a look.
Yeah, thanks for having me tonight.
You're welcome. And I